Hello, everyone. Welcome to the SIG Node meeting on May 13th, 2025. First up, we have some folks talking about in-place pod restarting. Anu, Sergey, and Don.
I'm not sure if Anu joined, but yeah, I can speak about it, and we have more people who will participate. This is a big meet. Want to say something? Do you want to say something? Or...
Oh, no, I just so said to maybe we want to make other topic talk and ping the Anu and then come back this one. Is that okay?
We can do that. Like, yeah, let's have
Yeah.
Anu.
Yeah, sure. Thanks. Yeah.
Maybe the next one, node capabilities.
Hey, hi. Can I get access to share my screen?
You should be able to now.
All right. So, is my screen visible?
Yes.
Sounds good. Hey everyone. So my name is Praveen and I work at Google, and I wanted to bring up this proposal for introducing node capabilities, mostly to gather initial feedback and also capture more use cases where this could potentially help. So, yeah, the problem that this proposal is trying to address is Cube Scheduler currently has limited understanding of what workload needs and what are the characteristics on the node which are needed for workload for pods to run as intended. It mostly kind of understands things like hardware resource requirements and make sure the node has enough resources before scheduling pods. But if we are thinking of more other features like kernel uh, features or runtime features or even kubelet features, we need other selection mechanisms like node labels and node selectors to basically make sure whatever the pod needs is, I mean, basically the pod is being mapped to the right node. So the reason for having the need for this node selection mechanisms is different nodes can have different configurations. This can be intended to for being able to address workload requirements, things like kernel modules or runtime configurations and so on. Or the other main reason could be because of version skew, the control plane is running at a higher version, and basically there are some newer features which are enabled on the control plane, and during the pod admission time the control plane thinks that this feature is available and it just schedules on the node, and older nodes do not have these features yet, and basically the pod would be won't be working, might not work as intended on these older nodes. So yeah, as I was saying, the current mechanisms to handle pod placements could be one, we use stains and tolerations. This is mostly intended for repelling pods from certain nodes, and this is a common pattern that is used for handling expensive nodes, like nodes with gpus and so on. And these nodes are tainted, and workloads are either manually or through admission webhooks. Tolerations are injected into these workload or pods to make sure they land on these nodes. The other the generic mechanism that is used is uh, labels. Basically we add labels for nodes which have specific kernel modules, for example security modules, and the pod is expected to have the right node selector or node affinity within it. But in many cases, specifically for these features, it could also be possible to basically infer this from within the pod spec. like either directly, like pod mentions that it needs a specific security module, for example, or indirectly, like basically looking at like other configurations in the pod spec. We could map this to like a node requirement, but like today we do not have like a standard way for the node to express these characteristics like back to the API server. So yeah, I think these are like I already mentioned some of these. Like the current mechanisms have some overhead, like specifically with labels and label selectors. It needs like manual operations. Like the cluster administrator should add labels, and like the pod like owner should know what labels to use on what pods. So yeah, that is like the operational overhead involved there. And specifically, if we miss adding these labels, it could result in like runtime failures. Like a pod could land on a node and later it could enter like a crash looping state where if it is relying on a specific runtime which is not configured the right way on the node and so on. Or like the thing that is harder to detect could be like basically the pod is running on the node, but it is running like suboptimally. Like it is basically running like it is not working as intended, but since it is not crashing, we think that like everything is fine. So that is like the harder problem to detect. And the other kind of operational overhead here is like every new kubelet or runtime feature should come up with its own like version skew management strategies, or like basically require the control plane and node to run, like the node to be updated to the version in like the control plane version. So yeah, this is like mostly specific to the version skew thing that I was mentioning about. uh yeah, like coming to the proposal itself, like the main objective of this proposal would be to make sure like we don't schedule pods when we know that the nodes cannot run them. Uh, and like the mechanism that is being proposed is like the kubelet is responsible for like discovering capabilities on the node, and like basically kubelet would know about like the features enabled and configurations, and it would also like talk to other like plugins like CRI or node plugins, or it will also like figure out like the kernel configuration and expose them through like node capabilities. And this would like the proposed method here is to use the existing like node status API, where we add like a map of string to basically indicate like the capabilities available on the node. In the doc that I've also linked in the meeting notes, I have explored like other alternatives, but seems like the node status is like the preferred approach, although it's like we can discuss more on the doc itself. And yeah, like uh, basically, as I was
Before you
saying,
go
like
too
with
deep
this.
into implementation details, like Francesca has a hand, maybe you can handle a hand, and then we have many items on agenda. Do you mind? Is it okay?
I would like, hey,
Yeah,
Sergey, thank you. I would like to Praveen to finish first. No problem. Thank you.
Okay.
yeah, I just have a couple more slides. So basically, yeah, like this could cover like kubelet features, runtime features, kernel and plugin features. And we would also need like a filter plugin which would fit in the like, existing kube scheduler framework, which would inspect like pod spec or like pod request and map them to like capabilities that are being advertised from the node. uh, so some of the requirements for anything that needs to be that can go into like node capability is like, one, it needs to be like scheduler relevant. So we should not be like adding like all of the configurations or feature flags. Like the second point kind of ties into this. Like basically we would need to be able to infer this, like that a pod needs this capability through the pod spec. And like the third one would be like it should be mostly static information that the kubelet can figure out during the bootstrap stage. This is to make sure like we are not running into some timing issues, like where when node comes up, we don't have a capability, then later like we publish the capability. So yeah, like we need to make sure the information is mostly static. And fourth one is like kubelet should be able to infer this from existing APIs that it uses to like talk to CRI or like node plugins and so on. So yeah, I think this is the crux of what I had. I have a couple more slides which go into some details, but we could do that on the doc as well. Yeah, Francesco, do you wanna?
Thank you. Thank you for the presentation. Thank you for bringing this up. This is an important topic. I shared some comments, but I would like to comment quickly on this forum. So, first of all, I like the overall concept. I see the problem which is we are trying to solve, and I agree those are problems could use a solution. Problem is I see with the proposal in the current shape is there are quite a few I won't call flags in a row. For example, the scope is pretty large. We are looking to add a new API object. There is a quite significant auto detection / inference part in this proposal. Each and every single aspect is manageable, but all of them combined make the proposal quite hard to digest and to pass through. So for example, I see the benefit on adding the API object, but I think we'll need a strong reason why. Okay, why we could not do that with existing tools like taints and labels? And the inference side, how relevant is the inference? How much benefit could we reap if we, for example, postpone the auto detection? Because doing things automatically is something that we need to be careful about, I think. So I would call for reassess the scope. This is my single most important comment, and try to have a very well-defined and precise and digestible scope, and then build on top of that later on, instead of solving all those problems in one go. Thank you.
Sounds good. So if I understand correctly, like you want the proposal to target like specifically kubelet things or like specifically runtime things. Like, is that the right way to look at like scope reduction?
There are multiple ways, but I will surely start that we surely think we should start with as small as possible scope, a minimum viable product if I can, and then build on top of that, but reach consensus on the real minimum part. But I don't want to steal too much of the spotlight, so we can keep going offline.
Sounds good. Thank you.
I guess I am the next. Okay.
Yeah.
Yeah, Praveen, so just today, about an hour ago, someone in a device management working group meeting proposed out of tree the DRA solution for CPUs, and their argument was their workload might require specific CPUs that are outside of traditional CPU requirements. Do you see? I can give the link to that. So essentially, do you see this can be handled using something like that? So that becomes an out of tree workload specific solution for using DRA? I'm not sure.
Not sure if I understood the whole question. Like,
So, the question is, they mentioned they're going to link the document I linked just now. They haven't linked the particular proposal there. They said they're going to link it after meeting. Look for today's May 13. There's an item called CPU in DRA. So the idea they had was that because they require specific features in CPU, they wanted to satisfy using DRA. as a resource claim. And I was just wondering, is there any overlap between what you are suggesting, where your workload might require specific kernel version or maybe specific driver to be installed on a node? Is this something, can we evaluate that path as that other person is taking?
Yeah, I think like maybe John added this, and I'm also a little familiar with the CPU for DRA proposal. I would also like in the doc, there is another proposal in place to specifically manage like DRA resources, because like resource claims and so on may not be available during the pod admission time. And basically with DRA, the problem, I mean, for node capabilities, the strong requirement is like to keep this static information. And with like DRA driver and so on, like it might take a while for them to come up after like the kubelet starts running. So I think like we can look at the other proposal for DRA, and maybe this may not, like node capabilities may not be the right approach, but yeah, like it, I mean, I think we can evaluate this further.
Yeah, it's possible there's no overlap. It's just that it was just fresh on my memory, and so I thought maybe I'll run
I can
that through you.
add the link to the other proposal specific to
Thanks.
DRA. Yeah.
Yeah, I mean, but I think this proposal is actually like a replacer of CPU manager, correct? So it's in the long term, or this DRA that you have shared.
I mean, maybe this could be used along with the other proposal, in the sense that like it can indicate if like CPU manager is enabled on the node or not. And that can be used to like in the scheduler to decide whether we look at node status allocatable or DRA like resource claim. I mean, I'm not sure of the details, but yeah, like this can expose like if something is enabled on the kubelet or not at a high level.
Yeah.
I wanted to respond to a couple of the comments that we've had so far. So I definitely agree that we need to be careful about scoping this. I think there's a risk that this could become sort of a grab bag of things, where like every KEP is adding a bunch of new capabilities and knobs and just like surfacing up a ton of information to the control plane that doesn't need to be there. So we do need to be careful about that. I think having some principles of like what can become a capability, so that each, when we're reviewing a KEP or code, we can be careful about kind of keeping that list constrained. I do think the first two requirements here do a pretty good job of scoping that down. I would relax the scheduler specific one a little bit. Thinking about in-place pod resize, that's not exactly a scheduler concern. It's kind of a request that comes in afterwards. But I'd say like first party controller relevant, and it needs to be automatically inferable from the pod spec. That already scopes it down quite a bit. The earlier version of this proposal included a bunch of details about hardware requirements and kind of like soft preferences. And I think kind of separating that out from the core proposal here will be helpful. I think to some extent, thinking about this as just addressing version skew. So at kind of a very basic level, we've got feature gate skew between the control plane and the kubelet. Then we've got version skew between the kubelet and the runtime, and to some extent, version skew between kubelet runtime and the kernel as well. So it's kind of addressing a lot of those problems there. And then the last point that I wanted to make is kind of thinking about this in relationship to labels. I think, yes, like we could implement this with labels. We could add every capability as a label on the node. We could have an admission plugin that infers the required capabilities and adds them to the pod's node selector. And we could do that all out of tree. But there are some performance implications of using labels if we end up adding quite a few. I think it also sort of makes it unclear a little bit which labels were added by the users, and sort of like mixes up the system requirements with the user requirements. And the idea is that these are things that are sort of automatically inferred and automatically marked as required, to kind of keep it like things that the user shouldn't have to be thinking about so much. I think that's all I wanted to say.
Thanks, Tim. So yeah, I think that's everything I had. Thanks for the discussion. I've noted down a few things. I'll address them in the doc, and maybe like we can iterate there.
Cool. Thanks, Praveen, for the beginning introduction. I'm looking forward to talking more on the KEP. Next up, we have Philip talking about the Node Lifecycle Working Group.
Hey, sorry about the sound. I will try to make it short. So we had our first meeting yesterday, and we decided on the exit criteria for the working group. So this would be the node maintenance feature, eviction request, and graceful node shutdown. And like this is something that we will also not discuss like the other features and efforts floating around. We will try to make this like inclusive forum for like everything connected to the pod and node lifecycle. And we will see how they perform, or how yeah, like we will observe what's happening in the future. But these three caps or features we will have as a exit criteria. So node maintenance, eviction request, and graceful node shutdown. Yeah, I would like to see what's your opinion on that.
Yeah, I think the one concern I have generally, but I think that sounds good, is just that we have the last couple of weeks, there's been a number of proposals that we have sort of like kind of chucked in the bucket of node lifecycle, like AJ's one about, I'm forgetting how we phrased it, but the
yeah, node readiness. Yeah.
The node readiness gates, exactly, yeah. And some other ones. And so I think it makes sense to focus this working group on this specific, like, basically node graceful shutdown set of cases. And also, I think if we continue to have these sort of node readiness problems come up, or generally like these other classes of things, maybe we might want to spin that out into a new working group so as to not sort of conflate the two, and to allow for the node graceful shutdown to be like the main priority of this specific working group.
Yeah, just one thing to add. These meetings will also serve like for us to explore the problem space. So we hope to have like presentations from people having problems regarding the non-maintenance or like the pod lifecycle, and so yeah, that like this will be a lot of that will be an exploration effort to see like what actually we want to solve. But I think like these three like main topics are these three main topics are the things we like probably know we want to solve. Like this, people already have like big issues regarding these.
Yeah, totally. I guess I find myself wondering, like Don or Sergey, or I know like when Philip like proposed this or a couple weeks ago, the concern was about scope. Does this like tightening of the scope sort of alleviate those concerns? Are there other sort of follow-up concerns about this?
Sorry, I missed yesterday's meeting and just too earlier. Not too earlier, but also it's not too late. So that's why. So unfortunately I missed. So those three caps, obviously, some I believe we all agree about the priority. Some agree about like graceful shutdown, right? So at least I think we need to address that problem. Some agree about the problem, but I'm not. I'm not sure that is the node life cycle problem, like the eviction request API. Right? So at least we think about we agree as the Kubernetes we agree the problem, but I might not agree that's the only node life cycle management problem. We did talk about that when I disagree about the proposal, the solution proposal that proposed there. But I agree that's the problem. We should join the effort to address that problem. The last one, declarative node. Last year I tried to invest some bandwidth to address that problem, but after talk to many people, I realized that might not the top priority. So, but there also have like the network require about the node readiness gateway, all those kind of other things. For me, maybe that's even higher priority compared to the declarative node. So I need to look at what's the goal, and because this is more like okay, here's the three caps we care about. We want that's the goal, and it's not like something like for the user perspective. Like what I say that some of the I agree of the problem, but not necessarily is we need to address in the node life cycle, right? So some is maybe it's too big, like declarative node maybe it's too big to address at this moment, and with not measurable return. Yeah, Philip, go ahead.
Yeah, one point to make is like these caps are like the point of them is not to like have right now the final solution to these problems. They are mostly like to show the space we want to explore. So like it might happen that like the solution will be different than it is in these caps because it's in very rough. So these are like the directions we would like to follow. And like that's and we know like it would solve a lot of use cases. And regarding the priorities, like we try to not to like prioritize or we cannot prioritize the caps that are existing. For example, the network problems, etc., the node readiness. So like I think first and foremost, this should serve as a forum to actually discuss these problems and like yeah, and like we added these as exit criteria as something concrete we already have, but since the other proposals are not like scoped well currently, yeah, so that's the major reason why we put these three there.
Okay.
Yeah, I think working group the main benefit of having a working group is that every cap wouldn't be just discussed in a vacuum, like by itself, like how this single cap is doing, but we can bring more voices on different views, like how valuable, like how important to solve this problem, and what kind of existing solutions currently already exist. Like every cap we discussed, like node readiness, like node capabilities, graceful, like declarative termination. it all has some alternative like do-it-yourself solutions. And what we're trying to make here is to find out what are the common problems that people do the same solution over and over again. And we can just support it in Kubernetes to make it better for everybody. I think working group is very good from that perspective, like collecting voices and collecting problems. From priority perspective, I'm not sure how to. I think graceful shutdown has a clearest priority because it's already implemented and like we have clear issues with that. So making sure that we polish the experience and GA it sounds like a very immediate goal that the working group can have to demonstrate success and how it's working. Yeah, and like regarding time, I don't think I will be able to join this time, at least not often. Yeah, go ahead.
Yeah, it was a hard time finding a good slot for everybody. So sorry about that. To everyone who is not able to join. Like we might try to reschedule in the future if there is a need. Like one point I will make us like we will also discuss like since we plan to have like a bunch of use cases or scenarios of like people like people solutions. We will like to propose creating a repo where we could actually share these the solution like problem translate.
You're breaking up for me. I don't know for everybody else. Yeah.
Sorry, is it better?
Yeah, now better. So you said that you want to start putting the scenarios in some repository. I think repository or like updating documentation, updating our test scenarios, it's all a good directions to have for working group to establish some foundation first. Yeah, I think it's a very important area. Like the fact that we have so many caps proposed in this area should demonstrate that we need to have those discussions. From meeting flow perspective, I don't think Anu joined. Do we want to put a topic a little bit higher up, or we want? I just want to make sure we have time for in-place restart.
I think we lost Philip for a second. Maybe I can ask it and you can rejoin. Since we kind of talked about scope, I think that was one of the takeaways from last time. What do you think? How do people feel like for what's next? Like, I think our goal is to see if we can, how we can take the working group forward and start meeting and merge that PR. I mean, what would be like our gaps? Like, what would be our next steps that people would say that we should look towards to moving in that direction? Or do people feel like, with the scope that Philip talked about, like, does that satisfy the concern? Or I guess like kind of looking for some guidance on where to look next.
Yeah, I think personally, just maybe reframing the proposal to be clearer that like the node graceful shutdown pieces are more really what we're focusing on in this working group. And maybe also even thinking about like a name change for the working group, because we're less about node lifecycle than specifically like node shutdown or like other things. I mean, we can think about expanding the scope later, but I think generally if the main output we expect of this working group is to address like graceful shutdown, eviction, API, and just the general like how do you turn off a node and make sure your workloads are like well cared for during that process, then I think maybe we should be clear about that in the working group charter. I don't know how other people feel.
Yeah, sounds good to me, at least. I just feel since the SIG network have the strong desire for the, this is basically came from the SIGNet, right? So from the node readiness gateway might not shut down. Also, it's belong of the node life cycle, right? So node readiness, right? So I hope that include in this one, because otherwise we basically, yeah, AJ risk, since you are the owner.
Yeah, thanks for all the discussions. I think like two aspects I want to talk about. First, the focus on this working group. I think that if the focus is on like how like a node has to be managed, like and like basically terminating and conditions around shutdown and like maintenance of the node is a concern. If that is thin, and if the readiness gates doesn't seem fit over there as a working group, that makes sense. But the second point I want to bring out is like the priority of this working group doesn't need to necessitate the priority for Kubernetes or the node itself, right? Like, I talked with storage folks, and they definitely like, a lot of hacks have been in place for like, expressing CSI readiness and how like, custom solutions are like having problematic in multiple deployments, right? Like, so at least I want to see like it's a node focus on this for network and storage requirements, like have this like a minimal goal and scope, and see if this could be a SIG node focus to start with. I think like I have like a short demo, don't have like time for this today. Next week I could plan for this, just minimally on scoping that for the bare requirements that node should target for like the fundamental network and storage readiness. I think like that's how I want to like see this could like go forward. I think like more generically we could expand as we discuss further, or like discuss more problems more generically. What do folks think about that? Since I discussed with like both the like network and storage, and especially network, they really see like a value in getting this as sooner than later, like in 1.34. So that's why wanted to like see how Node can prioritize like fundamental Kubernetes aspects for readiness.
Yeah, I do kind of feel like the current scope is a little bit, I see Philip has dropped also, so maybe we want to talk about this later. But I do feel like, the current scope is maybe a little less directly related, like less of a priority for Node. I do agree about that. And maybe someone like storage or, big apps, like it might fit a little bit better there. But I do think that we could be a stakeholder generally, but.
May I ask a quick follow-up? Does this, my question here is that node readiness doesn't fit in working group. Does it mean that it doesn't fit in node? Like more of a direct question. I feel it does, especially for the value we bring, because especially it's a node's signal, and the minimal ready signal we expose today is not enough for direct, requirements.
Yeah, I would say node readiness is more directly a node thing. Because that signal, is currently being reported by the queue, but it would continue to be. So I think that makes sense.
Philip, please.
Yeah, I think like in general, like we do not object like to adding, for example, the network or storage or other issues to the goals or like as the criteria of the working group. Like we are just trying to scope it to have like some clear solutions, which I'm not sure there are in these areas, but it doesn't mean like we are not trying to bring them in to this working group to be discussed and actually solved later. And if it becomes valuable to discuss this, we can even, I think, add it in the future to the criteria of the working group.
Yeah.
Sounds like we don't have much concern. except I raised some random points. Sorry. Go ahead.
That makes sense. I think I could bring it to a tighter scope and like have specific use cases calling out on storage and network, and circle this with a demo or like a more defined proposal next week for further feedback and how we could take this further.
Do we feel like we have a little closure on here? Do we have the next steps?
Yeah, sounds like we agreed. Some consensus, right?
Should we move on to in place pod restarting then?
Yeah, I can chat about it quickly, hoping to give other two topics sometime. So you should be able to see my screen now. We discussed some time ago in a conference how we handle different types of failures on devices, and one of the failure scenario was that training jobs that may have multiple pods running, they all need to run together, may waste a lot of time if you need to, on the reaction of one failure, to reschedule them all. That's why people coming up with different ways how to do this in-place restart, different do-it-yourself solutions that have a lot of hacks around them. So the idea is that you have multiple pods running, and then one of them becoming red, and then instead of scratching, like rescheduling the whole fleet of pods, we just reschedule one, and then everything else restart in place. This way, resources that you use for the training job wouldn't be preempted by something else, and you spend way less time to restart the training job from last checkpoint. This is a main idea, and like we describe this idea in this feature proposal. You can see on job sets. This feature proposal has a design doc, and in the end, it has some performance report and analysis, which are very indicative of how critical this issue is, especially for EIML workloads. So you can take a look and see how it works. We also have some proposed implementation that is full of hacks and workarounds. And that's why we think that we want to do some improvements on SIG Node, which makes SIG Node better in general, but also contributes to this scenario directly. So a couple of things that we want to propose here, and I will be making them in official caps like very shortly. This container failure policy, this document here. The idea here is that you will be able to somehow tell that specific container has a custom rules for restart. So instead of saying like it's either restart on failure or restart never, you should be able to say that the whole pod is restart never, but you can ignore the specific error and keep restarting the container. In this way, you should be able to express some pod failure policy on the job set overall, while you still allow container to keep restarting when it's well-known exit code, and well-known exit code will be reaction to this request to recycle in place. So in this recycle in place, in order for you to simplify this recycle in place, you want to completely exit the container and recreate the container, so there is no state left. I mean, minimal state left. And then this will be done through some exit code that will be ignored. So you have a pod that works with job sets and pod failure policy, but also can restart containers. This is one cap that's like least controversial. It was requested for a long time from SIGOps and workgroup badge, but I think time is now to contribute that and make it happen. And then another one is self-orchestration of pods in Kubernetes, which is very big in terms of like it introduces a completely new paradigm for Kubernetes. In this paradigm, we want to be able to say that one of the container in a pod has some orchestration capabilities. So specifically, in this example, we want to make sure that we want to allow one container to restart other containers. So like Kubelet will ask this orchestrating container what to do, and if container will decide to restart some other container, it will report back to Kubernetes saying like, please restart that other container, or please restart all other containers, and then Kubernetes will react accordingly. So it's like first step in this orchestration, and then orchestration you can think of so many scenarios, and we worked with Eduardo on other scenarios that you can think of for orchestrating containers. Some of them are futuristic, some of them are like closer, easier to justify, like come up with API for. So we will describe it a little bit more details on how API will be proposed, and it also will be a cap very soon. I don't know if anybody, like Eduardo, do you want to add something? Anybody else have questions?
I guess the one question I had on there, I guess one comment when I was looking over that doc really quick, it would be nice to make sure we have a good idea of how this plays with the pod failure policy. And it didn't seem like that was really kind of in scope in the design at the moment, but I think it is important to kind of think through that.
Yeah, definitely. That was the idea, to make it work with pod failure policy. It just wasn't described very well. I thought there were two caps, one for SIG apps and one for SIG Node, but it's a good idea to just explain in details like how it will work. Thank you for
Sorry,
feedback.
why would there be a separate cap for SIG apps? SIG Node owns this API, right?
Yeah, but SIG apps owns job pod failure policy, and like whether job needs to have restart policy never, and how to react on that.
Yeah, I guess the issue is pod failure policy is GA now, so I guess there'll be a new cap, but so it isn't as like I don't fully understand that one, because like we would have to have the container policy right now to do anything for the other cap.
Okay, I got the feedback, so we will try to understand who will be working on that for SIG apps and how to coordinate that. Because originally the idea was that we'll implement it on SIG Node, and then SIG apps will pick up this improvement. So we don't have to pick up it immediately, but the feedback is very true. Like we need to explain exactly how SIG apps will pick it up, so we will not we're not breaking it in future. So okay, it's good feedback. Thank you.
Yeah, I agree. I think we can maybe follow up on these documents, or in the corresponding caps as they move forward. Yeah. Does anyone else have anything I wanted to talk about here? John H., do you want to talk about this next one?
Yes. So this is a question about error handling between DRA kubelet plugins and the kubelet. So usually when a DRA driver responds with an error to the kubelet when the kubelet invokes it to prepare DRA resources, that error basically, like that pod will still get retried periodically. But if there's some sort of like catastrophic failure of a device in between the time it gets allocated and by the time the pod actually starts, then if that pod, given its current allocation, basically will never ever be able to start, then we'd like to be able for DRA drivers to communicate that to the kubelet, and essentially have the kubelet be hands off on that pod until it gets deleted somehow. So the question I had is if it's acceptable for the kubelet to set the status.phase of the pod to failed in that case. I've seen that some of the documentation implies that failed only happens like after containers restart. But I've seen that there are some admit handlers that do set the status or the phase to failed even before a container starts. And that would trigger like a runaway pod creation type thing. But there are ways where a DRA driver could proactively like prevent new pods from getting that same device scheduled. So maybe that's not as much of a concern there. So I was interested in getting just a quick kind of sniff test on if it's okay to set the status that phase to failed for pods in that case, or if there's a more acceptable way to handle that case.
I think it may be great to explore the way to to mark pod for readmission and then have DRA admit it or like fail admission. We also need to discuss how to react if a pod was scheduled but DRA plugin is not around any longer, or like not any longer, but like we don't even know whether DRA plugin here or it will be there. So should it be signal from DRA plugin, or Kubelet needs to figure out that pod is totally broken from that perspective?
Yeah, so I think this is the case where like the kubelet knows the DRA plugin is around, and the DRA plugin replies with some sort of well-formed error indicating like this is a permanent failure. Don't try to restart this pod, or don't try to start this pod at all. I think that's the specific case we're looking at here.
Yeah, John, this is we did talk about these use cases when we discussed earlier. Know the capability proposal. This is one of those we are thinking about, but it just overcomplicated. So that's why we make that like drop that for the initial proposal.
Yeah, the most common way to solve it is using some external controller on scheduler side that will detect the situation and do something about it. It's the easiest way to go without changing much of semantic on kubelet side.
So then what would the scheduler be using to indicate, or yeah, like what would the scheduler be looking for on the pod to check when it's failed in that case, if the kubelet doesn't set the pod to failed?
Scheduler don't know the pod had a dependency on the DRA. The scheduler only know the pod that had a dependency on accelerator. So that's the problem. This is why we have some like the node readiness kit proposal. We also have the node capability proposal. So we talk about those kind of things, and in-house, right? So offline, we even try to say, okay, how those two not proposal, but it's really complicated once we start to think about those kind of things. So then all the condition, all the status, all need to consider. And how reliable to think about this DRA driver is permanent failed. Who make that decision is permanent fail. That's also that. But this, we definitely need to solve this problem. I'm okay if we can reliably detect this. Or some things have to give us this is permanent fail. It's not a transient error. Then first thing we need the admission control. How in the node we also do the admission, right? So then we can reject it. And another thing it is we can we can set the figure if we need it, but how to reliable to do that? That's the question. I saw the Laura raised her hand. Yeah, Laura.
Yeah, I want to extract from this conversation, like if we take away the questions being asked of like, how can we detect, or like in what situations like do we detect, if we assume that like, yes, we have detected that this is not like the driver's not coming back, or whatever the situation that we decide is, this pod needs to be rescheduled. It needs to like bounce off this node, but like it had been scheduled here and Kubelet is going to try unless we do something else, is something that's responsible right now we're talking about kubelet being responsible, but maybe it's something else. Is something that's responsible for making that decision, setting that pod status as failed, a valid lifecycle choice that we can use as a way to signal that that is the case, like assuming that we already feel confident that that's what we want to do.
AJ, actually, you and I discussed this kind of, sorry, I'm overcomplicate that proposal again. So you and I discussed those kind of the different layer about the, right? So like the node, the readiness gateway. We cannot just use one lob to say this is node ready, right? So because the node could be not ready for certain workload, but ready for other workload. I don't want to hold all those kind of the placement. But the challenge part it is if this node for those special hardware and GPU, TPU that's expensive, then it's not ready because it's DI. Then I reuse this. The problem is just how to permanently detect this one, and so then the node can be repurposed for other workload, or we would rather hold that node, don't repurpose that one, and just fix this problem. So that's kind of like the challenge problem. I'm not sure I described this clearly to the John and Laura. AJ and I did discuss some similar situation for the node readiness gateway. Yeah, go ahead, AJ.
Yeah, thanks, Don. Yeah, I actually call that out as a extension in the proposal where workload describes or declares this is what I consider the node to be ready before I can be landed on the node. That's I think that like would need the node readiness as the core API to be available before, or I would think that like it's more like building on top of node readiness, but how to make this more generic rather than just focused on DRA. Maybe that's something we need to discuss and define. And I think that like we could explore that direction further.
I do want to say, while I do think this situation is that you're talking about is relevant, I think, or is important to address, I think the specific question here that John is asking is not about if we're rejecting something that at like a stage of like node readiness, but it's already been scheduled and bound to that pod, and kubelet is like making the sandbox for it and like continuing to retry. And in that situation, we want to like if we've assumed that we've already assumed like we want to bounce this pod out of here, we know like we don't want to try anymore, we've made some other cost analysis or something that we got to go, then that is why we want to address it from the pod failed perspective, and that it's like pod specific because it's about the ability of that pod to even run on this node and giving it the opportunity to be rescheduled. And I mean, maybe we can keep talking about this separately too, but to me that feels different from a solution that's based around node readiness gates or like trying to figure out if this should even be admitted. This is downstream of that potential issue.
So I think Laura, you're right. We need to detangle like discoverability of problem and reaction of this problem. Like some of the, I think the flow is generally acceptable if we clearly articulate how it will work with all the controllers like that control the pod. Like the worst case scenario, we entering some infinite loop. Like we didn't mark, like maybe in most cases just marking the resources like deleting the resource from resource slice will solve majority of problems, and then controller will detect that resource is deleted while pod has this resource using it. So controller can delete this thing. But I think there may be cases when there is a race condition or like true undiscoverable, like true problem with like DRA. Like DRA really cannot schedule the spot here. But if we wouldn't be able to discover to flow this information up to the scheduler, we will get into this infinite loop of scheduling and unscheduling the pod. So we need to avoid it and make sure that we clearly articulate when this flow will be applicable and how we'll avoid this infinite loop.
Understood.
Yeah, Sergey, just thinking out loud, I mean, a heartbeat solution or a probe, something like that, it could not be a solution.
Sorry, can you repeat that?
Yeah, I mean, a heartbeat approach would not be feasible.
Heartbeat from what to where?
There is no liveness probe before sandbox is created. So the problem is that pod is stuck in sandbox creation, and we want the array to somehow indicate that the sandbox will never be created, and the pod can go away now.
Yeah, but this is what I mean. I mean, if the DRA goes away, then you can just say that I'm alive or something like that. Or it's...
Yeah, so that what you're talking about is about the detection part, like has the driver really gone away, which for the purposes of this conversation, and I'm trying to kind of separate as that's like its own thing of how we detect that. But then what we're asking right now is, let's say we have successfully detected that. How can we get a pod that is like continuing to retry because it has been scheduled and bound to this node to indicate up to the scheduler, never mind, through kubelet and to the scheduler, never mind, let's go somewhere else. And I think what I'm hearing is that it is reasonable to consider that to be like a pod failure condition. We can have something that's responsible to put the failed state on that pod so that everything else can pick it up on the way up. And what Sergey is saying as well is that we need to articulate exactly what the situation is that could occur so that it's clear to us what sort of race conditions may happen between the scheduler, the driver coming back up, what delays are happening where that like may or may not have the bounce happen over and over again.
Okay, sounds good. Thanks.
But yeah, I agree with you that what you're saying is a valid part of the diagnostic step upstream of, are we in a situation where we know we can't come back? So yeah, I agree with you there.
Sounds good. Thanks for the discussion, everybody. I think we've already gone way over. So if anybody has any other thoughts, please leave them in that issue that I linked in the doc. Otherwise, I think I will get a KEP going for this like scope just to the DRA case, just to try to keep that as narrow as possible. And we can take that from there.
Thank you for bringing it in. I think we're heavily out of time. Thank you everybody who hanged longer. And see you next time.
Thank you very much. Bye-bye.